All right. Hello and welcome everybody to this live stream. My name is Rhys Davis, as you should be able to see on the screen here. And joining me today is David Beaumont. Do you want to introduce yourself quickly, David?
Okay, sure. Hello. Thank you very much, Rhys. It's a real pleasure to be here with you today. I think it is a great initiative to have this kind of open sessions for discussing these topics and allowing people to ask anything. That's the purpose of this event. So, okay, let me introduce myself very briefly. My name is David Beamonte, and I am telecommunications engineer with background in embedded systems and electronics in different roles. And now I am product manager of IoT and embedded systems in Canonical. So, okay, that's my brief introduction.
Great. So just quickly before we get started, we are going to be talking about Ubuntu Core 20 today and answering some of the questions that we have received from places on social media and in forums. Just a quick caveat before we get started. This is our first time doing this particular kind of stream, so bear with us if there's any problems. You'll see me looking off in this direction a few times, which is where I'm looking at stream chats and forum posts to make sure I get all the questions in the right place. We also have some people in the chat there doing some moderation. So if there's any questions that appear there that I missed, they're going to send them to me so that toward the end, during a more open receiving questions part of the stream, I'll be able to see those and ask those to David here again. So feel free to ask any questions you have down in the chat, or if you hear anything that you're interested in or you want to learn any more, there's always lots of links down in the doobly-doo in the description below. So poke around in there. I know if you want to get into more detail, coming up is a webinar that David is doing with Canonical on a more in-depth and a specific thing about Ubuntu Core 20. But here it's going to be a bit more of an informal sort of discussion, and we're going to talk things through. So settle in. As you might be aware, this should be going for around an hour, but there's no hard cut there. So we might go a little bit over, we might go a little bit under. I hope that's not too much of a problem. So if you're ready, David, we'll get into it.
Yeah, sure. We can start whenever you want.
So first things first, I thought we could start by telling the story of Ubuntu Core and how we got started, how these things came around. Would you mind taking that away?
Yeah, maybe because maybe before that, Amber, you could just bring up a couple of slides that we have prepared for this, and because I think that I have the feeling many times that many people get confused about what Ubuntu Core is. And I would like to try to clarify some aspects in 4 slides. The first important thing that we must keep in mind is that Ubuntu Core is Ubuntu. Ubuntu is one of the most popular distributions among developers, so the learning curve is very, very fast for them, and it's also productivity. Ubuntu Core is a lightweight cross version of Ubuntu with a limited set of packages by default, which keeps it simple and constrained, and it is targeted for IoT and edge products. The second important thing to say is that Ubuntu Core is an operating system fully built from snaps. This is something that makes it unique among the rest of the solutions available in the market or in the open source community. Maybe we will get more deeper in what snaps are later on. Ubuntu Core has been designed with the goal of creating the most secure embedded Linux ever. We strongly believe that every single device, even the smallest one, should be trustworthy and secure. And Ubuntu Core was born with that premise. Features like secure boot, full disk encryption, or even the secure nature of snaps are good examples of this security target of Ubuntu Core. Finally, the whole process of image generation, device programming, and onboarding has been designed for optimum performance as an enterprise-grade solution, which is targeted for production at mass scale with minimum human interaction. The goal is to simplify operations and reduce maintenance costs, making the devices ultra-reliable and easy to maintain. And of course, as a secure operating system, upgrades and CV fixing are of great importance, and we offer for that long-term support services for up to 10 years. So that's our way of allowing our final users and customers to focus on their application development and leave us to handle the rest. So what we have created, as I mentioned before, with the second sentence of the Ubuntu Core is fully built from snaps. What we have created is a new operating system paradigm. Okay? Classic distributions architecture are based on packages which simply interrelate with each other, but with the appropriate permissions, they have full access to the full system. In Ubuntu Core, applications are based on snaps and are totally isolated from each other, and they can only interact with the system through the interfaces that are very well defined. This, of course, delivers better security and a stronger resiliency. Even the bootloader, the kernel, and the distribution base are snaps in Ubuntu Core. Okay, not only the applications, but also the system. Everything is a snap, and only snaps which are strictly confined can be installed. So I'm talking about the snaps. For those who don't know what the snaps are containerized software packages which are bundled with their dependencies and that are isolated from other packages through those interfaces that I mentioned before. They are not containers like Dockers, okay, which emulate the operating system, but actually there are applications that run on top of the operating system. So the main value proposition of Ubuntu Core is to allow our customers to focus on their application development, on their business case, forgetting about operating system reliability, security, and so on. Okay, so with Ubuntu Core, our customers can reduce dramatically the time to market, okay, can have tools that simplify operations, such as the recovery mode, and save money. Okay? And they can also forget about security because their devices will be inherently secure and receive security patches and, of course, have up to 10 years of support. So what's our goal? Our goal is to offer an operating system which can be used across all the IoT verticals, such as IoT gateways, AML, consumer electronics, digital signage, robotics, automotive, industry, or other examples, okay? Just a reference for all the IoT ecosystem of applications. So that's my brief introduction of what Ubuntu Core is, okay? So I think that this is a good starting point for those who don't know what Ubuntu Core is, and from this we can start the conversation.
All right. Yeah, that's like you say, it's a good starting point. So when I was looking around for these questions and reading these things through, there was a few sort of general questions from people who didn't know particularly what Ubuntu Core is that might have been answered there. But I think a good question to start with is why did we make Ubuntu Core in the first place? What's the need? What's the point? I think that's a good place to start. So
yeah, I think so. Okay, I think that the short answer could be that we saw there was a gap and a need in the market, and we went for it. Okay, that would be the short answer. But of course, there is a story behind. And the answer is, the long answer, the story is a little bit more complex. Okay, so as I have mentioned, most of the embedded operating systems followed traditional rules of the operating system with architecture as the one I showed before. So portability and dealing with dependencies has always been a major headache for developers. Everyone who has worked on embedded systems have suffered that. For instance, to change versioning, kernel, application libraries, cross-dependencies between them and the different versions are a major headache for everybody. So some years ago, there started to appear new ways of dealing with that, okay? Of course, there was something that already existed, which was virtualization, hardware emulation, okay, which has already existed for a long time, but it is, of course, not a good solution for embedded systems because embedded systems are typically with low resources, so they are not suitable for running hardware emulation, okay? But there started to appear containers, okay? Containers are operating system emulation, okay? And of course, there are kind of good solutions for tackling that problem of portability and isolation of applications and so on. So applications could get independent from the underlying operating system and dependencies and so on. Okay, so that seemed to be perfect. Okay, but the problem is that containers are still resource-hungry pieces of software. Okay, they need to have a good processor, large amount of RAM, storage, and so on. Okay, so they are still not suitable for all embedded systems or platforms. Nowadays, it is true that they can be used in embedded systems because hardware is getting more powerful every day. Okay, so you can use Dockers, but not or containers, but you cannot use them in all the different platforms and embedded systems that we have. Okay, so snaps, what I mentioned before, are a great alternative for that. Okay, they just sit in the middle of containers and traditional packages such as Debian packages or RPMs or whatever. Okay, so because they are just applications which are bundled with their dependencies. Okay, they are totally isolated from the system. So the tricky point is that those applications feel as if they were running on top of a specific Ubuntu LTS version. Okay, it can be 16, 18, or 20, because every snap is based on the core version. Okay, so it is not an operating system emulation as containers, but an abstraction layer. So with the snaps, you can get rid of portability or dependency issues, okay? But you also benefit from other things like transactional upgrades, rollbacks if applications fails, application upgrades fails, channel tracking for versioning control with different levels of risk and so on. Okay? And additionally, as they are a simpler solution than containers, they have a lower footprint, consume fewer resources, okay, and have a better performance. So they are perfect for embedded systems. So why not create a full operating system based on that, okay, based on the snaps? So that's why, and that's how Ubuntu Core was born. The problem was, okay, we have the applications snapped, but we need to snap the full operating system. So that's what our engineers did. Our engineers did the tasks that every single embedded project needs to do. I mean, to port the bootloader, the kernel, and so on, and they package that into snaps. Okay, so every single piece of software which is running on Ubuntu Core is a snap and is totally isolated and strictly confined, and so on. So that's something that our engineers did when we designed and we developed Ubuntu Core, and now our customers can take benefit from, okay, because that's something that it is already done, and they don't need to be reinventing the wheel every time. So that's great. So in summary, there is nothing quite like Ubuntu Core. Okay? There is no similar product in the market with the same approach. This is like a new paradigm in some way.
Mm-hmm. So there's nothing like Ubuntu Core. Cool. That's I like that. That's a good tagline. But so you mentioned, so if Ubuntu Core is an operating system built up of snaps and made up of snaps, obviously things existed before snaps, right? There was Docker containers and there's debs and flatpaks and so on and so forth. So I guess another good question along the same vein is why snaps? Why create snaps? Why use snaps in this way?
Yeah, it's a good question too. Okay, I have roughly explained what snaps are, the difference between the different ways of deploying applications. Mm-hmm. Okay, we have like 4 different ways of deploying applications in a portable way. Okay, we have those traditional packages on one end. We have hardware virtualization on the other end, okay, which would be what we know as VMware or whatever, okay? And we also have Dockers and snaps just sitting in the middle of that, okay? The traditional packages are good for any kind of application, okay? They are perfect for that, but they are a headache for developers and for portability. Okay, so that's the major problem when you want to reuse software and deploy workloads and so on. So, okay, with virtual machines, you have very perfect solution for deploying full machines and so on. That's very heavy. Docker is kind of lightweight virtualization, so you are just taking benefit of an operating system emulation. And it's perfect for deployment of portable applications and workloads. That's why it is very, very, very extended nowadays, and the use along with Kubernetes, kind of the reference solutions for that. Okay, but snaps, as I mentioned before, snaps and Flatpak is a kind of different flavor of snap. Okay, a different way of snaps are simpler in the way that they do the same, just the encapsulation, the applications, but in a very simple way, just with the dependencies and with an abstraction layer which allows them to feel like if they were in the base operating system. So every solution has its niche, has its use case. Okay, every solution is good for what it is. Okay, so for instance, in terms of security and isolation, okay, snaps are perfect because they are totally isolated from the rest of the system. So it is very difficult to break the system using snaps. Okay, the performance is great. Okay, you can. It depends on the way you it's a kind of trade-off. Okay, you can use different compression schemes for snaps. Okay, so of course, when you talk about compression, you take some time to start the application and so on. Okay, so just you have to decide if you prefer a more compressed package or a faster package. Okay, but in any way,
it depends on that use case, right? Depends on if you're using your snap on your desktop or if you're using your snap in your embedded device.
Anyway, it is faster than Dockers. Okay?
Right.
So in summary, okay, for instance, you can use snap packages for running applications like VLC, a browser, or whatever on top of the operating system, but you cannot do that with Docker. Okay, so that's roughly the difference between the different ways of deploying packages.
Okay. Cool. Good. So that covers the wide snaps. That makes a lot of sense. I'm just going over looking at the questions here. Yeah. Okay. Yeah. Cool. I think that covers generally the why bother using snaps kind of thing. And I think the answer, well, a lot of what you're saying is a lot of good things about how snaps are good for what snaps do, and use snaps for where snaps are good, right? A lot of questions that came with questions about snaps and why snaps and so on was a lot of things around where you can get snaps from and how you can contribute to that sort of that Linux app ecosystem, if you will, right? So we have the idea of the Snap Store and Snapcraft and how this is the ecosystem of snaps and snap applications and so on and so forth. And I wondered if you could just speak a little bit about the Snap Store and Snapcraft specifically and their relationship in the ecosystem of snaps.
Okay, that's great. The first question is why is Snap Store? Okay, I think that would be a good question. Okay, we already have that concept of repositories for the traditional packages. Okay, so why another kind of a store, another way of deploying applications and so on? I think that everyone who has been working with repositories and traditional packages, once he or she is trying to use something which is just a little bit outside the main branches, it becomes a complete mess. Okay, you need to start adding different repositories, and maybe they are going to break your system or other applications. Dependencies are okay. That's a complete mess. Okay, so the first thing that we thought when we were designing the snaps is that there are two different worlds of customers. Okay, we have the developers and the normal users, and they have different motivations and they have different needs. Developers, for instance, need to test unstable applications, okay, which eventually can break the system. But normal users want stability. Okay, the normal users can be desktop users, okay, for instance, or just server administrators. The desktop users just want a good desktop experience and that to be stable and so on. Server admins just want to get stuck to some specific version for a long time because they don't want it to break at any point and so on. Okay, so since the very beginning, we realized that a new way of tracking versions was needed. Okay, so that's why the concept of channel, okay, was created. a channel is a way that we could say the version of a Snap, okay, is tracked. And the channel is comprised of 3 different items. There is a track, there is a risk, and there is an optional branch. The track indicates the major software release of the Snap, okay? The risk identifies the maturity or stability of the release of the Snap. And the optional branch is typically used for development purposes, for trying a specific feature or whatever, okay? So this new versioning tracking scheme and all the security features that have mentioned before needed a dedicated store, okay? So among other reasons, that's one of the first reasons why we thought there was needed a dedicated store. There is also a lot of controversy around the open source nature about of the store, okay? But okay, we must think that the first thing is that the Snapd and Snapcraft are open source. Everybody can install any kind of package using that, okay? But the key point is that the store is critical. It's something that you must trust. If we think, for instance, on the Apple Store, Google Play, all the stores that we are used to for our daily use, okay, we want them to be secure and reliable, okay. So Canonical decided to host that store to offer a better service, okay. And if this store, the source code was open source, there would surely be a very fragmented ecosystem of stores, okay, surely. Many of them would be very well maintained, surely, but others maybe not, okay. So if you have some stores which are not well maintained, this is going to lower the standard, and we know that this brings suspicion to the technology and so on. So avoiding a fragmented ecosystem of stores and providing a career-grade store experience, okay, was the major goal. The good news is that the store, which is hosted by Canonical, is public and it can be used for free. Okay? As Canonical is always willing to support the open source projects and which want to be published there without any problem.
Okay, that's good. You mentioned as part of the store, there's the tracks and the channels and these things. And I know from asking around that that's something that lots of folks are interested in. Lots of people take a lot of interest in, right? In the tracking and upgrading their software, keeping things up to date. That's a classic concern among people who use other unnamed operating systems, right? But I wonder if you could speak a little bit more about that specifically, about the automatic updates and upgrades feature.
Okay, yeah, this is closely related to what we have discussed before, okay, because we have 2 different kinds of customers, okay? The normal users who just want to have a very good experience, a very good and a very secure operating system, okay? For those kind of customers, automatic upgrades are perfect, and that's what we provide, okay? And we have the developers. The developers sometimes don't want their system to be updated because maybe this is getting conflicted with their developments or whatever, okay? So for both worlds, okay, we have that automatic upgrades for the normal customers, and developers can, of course, disable these upgrades. Maybe it's a little bit tricky, okay? It is not out of the box that you can select that in the application, but you can do that, and it is very well documented in our forums and in our documentation and so on. So, but yes, I think that automatic upgrades are definitely a very good thing for keeping a very high standard of quality of the operating system, and of course, and mainly to improve security.
Okay. So that's the perspective of developers and the general person, right? The person who's just using Snaps for the day-to-day activity. It seems like those 2 things are very can be considered quite separately, right? When you're talking about features of Snaps and Snapcraft and so on. And what about the 2 instances you mentioned? You touched on briefly earlier of the purposes of Snaps, right? So how do users and customers react to automatic updates on Core specifically, for example, for embedded devices, not for say a desktop?
Okay, yeah, this is a completely new world, okay? Because our customers, instead of being people are devices, okay? Our customer, I mean our users, okay? So who are going to be receiving those upgrades are not going to be the PCs from some people, okay, but the devices themselves, okay? So
right.
So in this case, our customers, who are the companies who are deploying this fleet of devices and so on, they feel that it is absolutely necessary. Okay, they want to keep up to date their devices. Okay, they want to have the latest patches applied and so on. We know that security is going to be one of the major concerns for the next decade in IoT world, okay? Because we are going to be monitored by IoT gateways. We are going to have devices which is collecting data from our energy consumption, or maybe more critical information from I don't know, from hospitals or whatever. Okay, so everything needs to be secure and needs to be keep updated the soonest possible if there are some patches to be applied in the security scale.
Right. Okay. So two different worlds, two different ways of looking at things, two different audiences, and so on. So part of what we're here to talk about today, right, is Ubuntu Core 20 specifically. There's been releases of Ubuntu Core before, and it seems like one of the things you're talking about here as one of the key features of Ubuntu Core and for specifically for embedded devices is security. I wonder if you could speak a little about the new features or most relevant features in Ubuntu Core 20 that have come around now. What are the new things that people should look for?
Okay, Ubuntu Core is right now we have released the third release. Okay, this is a kind of mature product.
The third is 20, right? Ubuntu Core 20 is the third. Okay.
16, 18, 20. Okay, this is the third release of Ubuntu Core. So in every single new release of Ubuntu Core, of course, we are adding new features which are targeted for some specific purpose. In Ubuntu Core 20, the target was to improve security and simplify operations and maintenance tasks. Okay, those were the major targets in Ubuntu Core 20.
Okay, so maybe let's go into them a little bit further, right? So specifically, which security features does Ubuntu Core 20 bring to the table?
Okay, related to security, we have we could say three different things. I think the first one would be snaps. Okay, as we have mentioned before, snaps are inherently secure. Okay, so it provides the first level of security. Just the applications and the system and so on everything is confined and secured and so on. But there has been added in Ubuntu Core specifically, in Ubuntu Core 20, specifically two new features, which are secure boot and full disk encryption. Secure boot is the way that the system has to secure the boot process. Okay, so you can protect against vulnerabilities at boot time. Okay? The BIOS, okay, verifies the integrity of the firmware. Okay, so it decides if it is the right one or not. If there is any kind of reflashing or corruption or whatever, okay, the device is not going to boot because it is not well signed and it is not identified as a secure image. Okay, and for that purpose, you need on board a TPM, which is an specific piece of silicon, a chipset. Okay, a trusted platform module, which is where the secrets and the certificates are stored. So the process of securing the boot is done in the factory. The first time that the device boots on the factory is capable of just generating their own keys, storing in the TPM, and then no longer you can have access to those keys. The full system is protected, and that's it. So it is zero maintenance and zero touch, zero human interaction for that purpose. Okay, and it is very secure, but because you don't need any other interaction for that process during the boot process and so on. Okay, full disk encryption works in a very similar way. Every information that we store in the devices is very critical. We have the firmware and we have the data. So both, we want them to be protected. The firmware, because we don't want that maybe other companies can extract that information and clone our software and so on. Okay, that's one of the critical parts for protecting just our software. And the second thing is protecting the data. Okay, so with full disk encryption, you can encrypt every single partition, or every single partition of the system gets encrypted. Okay, so for that purpose, TPM is also used. That's where there is where the secrets are stored for the cryptographical methods that are used. Okay, and these security features are, as I mentioned, out-of-the-box features.
Right. So that's Snaps, Secure Boot, full disk encryption, and all of this good stuff that comes with those. Okay, cool. There's I'm assuming there's web pages and there's webinars and things like that people will be able to look into if there's more detail on these things. That's right.
Yeah, of course.
Yeah, I think some of those should be in the description down below. The other thing you mentioned comes with Ubuntu Core 20 with security is operations and maintenance, right? Are there any new specific features that talk specifically to them? Maybe you can speak to a little bit of the problems that these things solve as well.
Yeah, you're right. The other features are related to operations and maintenance, and the specific feature is called recovery systems, and a recovery mode for entering a way of recovering the system. Okay, for doing maintenance tasks. Okay, so what's the purpose of this? The purpose is that we know that capex, the hardware costs is getting lower. Okay, it's getting more and more a commodity. Every hardware device, every single device is getting a commodity. So these expenses are giving way to OPEX. I mean, to the operation expenses that we need to face whenever something wrong happens. Okay, for instance, when the device gets corrupted or it doesn't boot because of an upgrade or whatever. Okay, so what you expect from a device which is in field is to be low touch device maintenance. Okay, so you expect that it is reliable, that it has self-healing mechanisms, that it has the ability of remote operations. Okay, so recovery mode, reliability and self-healing mechanisms are out-of-the-box features of Ubuntu Core. Okay, reliability is everything that we have mentioned so far. Self-healing, you can get that just because of, I mean, this is a way of expressing that the devices, when you upgrade and this upgrade fails because of whatever, okay, then it can automatically do a rollback to a previous version. Okay, so that's fine because the device is not going to get bricked. Okay. So the ability of remote operations allow you to remotely enter a mode where you can recover a system which is for any reason no longer responding. For instance, because an application is not running. As applications are isolated, okay, this is not going to affect the whole system. So the system provides you with a way to reboot it in a specific mode, in that recovery mode, so that you can do maintenance tasks and recover that device. And you can use CLI or API, or even at good time with commands, you can also enter that mode.
Okay, cool. So recovery mode and all the things that go with that. So if those are the two big themes that cool. Turn the light on. Nice. Now we can see you. Great. Yep.
Sorry for that.
Yeah. No worries. Okay, so if those are the two main threads in the Ubuntu Core 20, right? Is there what about any other particular new things, any new features? Maybe there's things that you can talk about that's in the works, maybe still, or anything. Maybe there's new architectures. What else is new in Ubuntu Core 20?
Okay, apart from this, there are other internal technical improvements. There are always many improvements, and of course, we are already thinking in new improvements for next release for Ubuntu Core 22. Okay, next year. But okay, those are the major ones, and then of course you can get to the changelog and the release notes so that you can check the whole list of different improvements that you have in Ubuntu Core 20.
Right, that's probably better than doing a laundry list here, right? So for anyone watching live, that link might not be in the description, but if you're not watching live and you're watching this in the future, that link should be in the description to the release notes and learning more specifically about Ubuntu Core 20.
Yeah.
To the next thing, so moving away from that, thank you for that information. The next thing is some people, and this comes up a lot when we talk about open source things and what Canonical does. Is the next thing people ask is how Ubuntu Core 20, how it pays for itself, right? Where does the money come from? If all of these things are open source and the Snap ecosystem is this growing open source thing, and Ubuntu Core 20 is the operating system made up of these open source things, how does that? How can we keep going?
Yeah, that's a good question, and I think that's the typical question for all the companies which are using open source software. Okay, right. So that's the typical one. Well, the first thing is that you can use Ubuntu Core for free, as we have mentioned before. Okay, it's an open source project. You can, it has maybe some constraints. You can use precompiled images, and you can generate your own custom image, but you need to use predefined kernel gadget snaps, and on top of that, adding your own snaps, okay, which are in the public store. That's the way that you can use Ubuntu Core for free. But and then we have in parallel what Canonical can offer their customers. Okay, I think that I will classify the different ways that we have to interact with our customers in two different ways. Okay, the first one is product acceleration. Okay, it's how we can reduce the time to market for our customers. Okay, I have been working with embedded systems for a long time. Okay, I have used many open source projects like Buildroot, Yocto. We are having a webinar next week about this topic.
Good plug.
Okay, yeah, but I mean, I know how painful it is to work with that. Yeah, great if you have time, if you have budget, if you want to get muddy into everything. Okay, but it is not a great solution for having a device into the market very fast. Okay, so again, maybe the first one is difficult, and the rest ones you can do that, but you need a lot of effort for doing so. Okay, so the first thing is that from a Canonical perspective, we can help our customers to reduce the time to market dramatically. Okay, we can also certify their devices. Okay, so that other people can use them and know that they are Ubuntu Core compliant. That's another way for those customers to get money from that. Okay, so for this purpose, for this product acceleration purpose, we have two different programs. The first one is device enablement, which is typically oriented to ODMs and OEMs, which is a way of enabling and certifying new boards. Okay. And another one is the Smart Start, which is the way that we have for accelerating customers' projects which are based on certified boards. Okay, so this is a much cheaper product. Okay, it's our entry point, we would say. And there are some features related to that. For instance, we provide some up to 3 applications to be snapped. We can manage up to 100 devices. There are engineering support. Okay, some features that you can check in the website. Okay, apart from this product acceleration scheme, we have everything which is related to operations and security and so on. We have the store with periodical upgrades. which provides CD fixing, and the pricing model is based on volume and SLA. You have the free tier. Okay, you can use that for free with a specific constraints. Okay, and then depending on the SLA and the volume and so on, okay, you have different pricing. That's also on the website, and we also have support, trainings, consulting, any other ways of helping our customers to have a very, very good product very fast in the market.
Okay. So it's a lot of you mentioned OEMs and ODMs and customers who want to get and people who want to get from prototype to market quickly, right? And that's where the money comes from. It comes from people wanting Canonical's help. But the vast majority of users and the vast majority of interest we get is around. It can be around around hobbyist type things, right? Around things like Raspberry Pis and those kind of different things, and all of that none of that's paid for, right? All of that is taken care of. You can just smack Ubuntu Core on your Pi and off you go, right?
Yeah, that's right. Okay, so Raspberry Pi is a very good example. You can Raspberry Pi is a certified device. Okay, so you can deploy Ubuntu Core without any problem there, and just deploy your application. That's the perfect example.
Okay, good, cool. All right, so that more or less reaches the end of the notes I made on questions that we found in forums and on Twitter and places like that. So I'm gonna maybe get a little bit more specific. I will say thank you for people who've been asking questions in the chat, and thanks to our moderators for answering some of those. That's been super helpful. Let me see here. Let's move on down the screen. Okay. Once we get there, here we go. So let's have a look.
I hope that our people in the background are just answering questions, because I see there are tens of questions. So, but yes.
Yep. Okay. So
yeah.
So here we go. So this is another one. Oh, actually, I think we took this one from the forum before. So we do have here we go. So the last two things we talked about were support for different devices and how people can get their devices to market quickly, and who's interested in these things. And something that a lot of people are interested in, that we know from people talking to us about Ubuntu Core and things, is fleet management, right? Is this concept of being able to manage and update fleets. And is that something that Ubuntu Core deals with specifically, or is that something that we're not addressing yet?
Okay. Right now, we prefer to be agnostic of that. There are many platforms that deal with that. So most of them are our customers, actually. Okay, so we want to integrate in those platforms, but of course, we maybe in a mid-term or long-term start working on a specific management platform. But so far, we are just integrating in third-party platforms. In fact, there are some snaps that you can find in a Snap Store, which are just agents that we have ported, okay, that we have snapped of different platforms, so that you can manage your devices from those different platforms. And that's our current approach of that.
Mm-hmm. Okay, so there's agents and things, and there's snaps in the store to do that more specifically, and of course there's an element of fleet management just in the Snapcraft features, right? In tracks and update channels and so on and so forth. Okay. Here we go. The roadmap of Ubuntu Core mentions real-time capability for future releases. Are there resources available on this topic? What are we considering here? What's the thinking around real time at the moment? And obviously only tell us what you can tell us.
Real time is a very controversial topic for Linux, okay? Because we know that critical or real time for critical applications is mostly done by microcontrollers, okay, and not by Linux-based microprocessors. But of course, there are some efforts with those real-time preemptive patches. Okay, so that you can apply to Linux and have a very good control of the latency and the and how the events are dealt with in a very predictive way and so on. Okay, so and yes, everybody is working on that. There exists those patches for applying to Linux, and yes, we are working on that, but we don't have right now a solution for that. But yes, we are working on that, of course, as the rest of the people are doing right now.
Okay, cool. We're working on it, and we'll communicate things more details when possible. Right. So the next question I see here is, with Ubuntu Core 18, I was able to create a custom image with locally built snaps. Snaps not registered in the store. Is this approach no longer supported with Ubuntu Core 20?
Okay, yeah, if I understand correctly, okay, what this person is asking is that he can do something that he could do before, okay, but what he wants to do is actually a developer feature, okay? So we consider that a developer feature, so we allow that to be done. It is possible to be done right now, but it is no longer possible with the standard model assertion, okay? So you need a dangerous grade model assertion for doing that. But yes, it is possible, okay? But it is just a way of increasing security in Ubuntu Core 20 that we have just moved this feature towards the dangerous grade model assertion mode.
Okay. So it's possible to do. It might be a little bit. It might take some reading to get involved, but if you're doing that kind of thing, I don't expect the reading is something that you shy away from, right? Next question here is. As I understand, there are no desktop GUI sessions possible with the Ubuntu Core 20. I think Ubuntu Core would be a great platform for kiosk applications. Would this be possible maybe in upcoming releases?
Yeah, I totally agree with the person who has done this question, because in fact, Ubuntu Core is a perfect application, or is a perfect operating system for kiosk applications. What we use is Mir. Mir is a framework for developing applications and developing kiosks. Okay, so you can develop your own kiosk applications based on kiosk and running on top of Ubuntu Core. Okay, there are some examples. There are some examples in the App Store, I think, and I think that I'm sure that there is information in the forums. Okay. But if not, of course, this person can get in touch with us, and we will provide him with a better answer or more detailed answer.
Right. I think we see this kind of thing happening a lot. It's certainly possible, and it's cool. Next thing, and I saw this one come up in the beginning of the chat, right at the start. If I can scroll through, this is a similar question to one that was answered before. But let's answer it here anyway for people who've come late or anything like that. Will Ubuntu Core support? Will or does might be a better way of questioning. Will Ubuntu Core support ARM devices now or in the future?
Ubuntu Core does support ARM platforms. In fact, Raspberry Pi is an ARM-based platform. There are others ARM-based platforms that we support, and we are continuously adding new platforms based on ARM to our certified list of devices. I think that the best way to know which are the certified platforms and so on is to go to our website and to surf in our certified list of devices. And there you can find, and I think that it is possible to filter them by architecture. Not sure, but it is very simple to just reach to the different devices that are certified. Okay. Yeah.
Neat. Cool. Head over to the website. There's ubuntu.com/core, ubuntu.com/IoT, and there's information there, right? Great. Let's have a look what else we've got going on here. Let's look at the time. Okay, so since we're starting to trail off, I think questions are being answered in the chats pretty well. So yeah. Yeah, those are all the questions that people are sending me. So I think we'll start wrapping these things up. Like I said at the beginning, everybody, there should be links in the description. And if you're not watching this live, we'll put extra links in the description that we talked about here. So they should be there as well. Thank you, David, for joining me in this. I hope you enjoyed yourself as much as I hope.
I think we had a good time.
Yeah, I think we had a good time. Yeah.
Yes.
Happy Thursday.
Yeah, I think that the most important thing for this kind of events is that we want to show how Ubuntu Core works, and we want to make everybody understand the differences between Ubuntu Core and Ubuntu and other operating systems. So it is great to get feedback from people, get questions. So I think it is very helpful for everybody. And yes, you mentioned before that we are having also in parallel some webinars. Okay, since the launch of Core 20, we've had a couple of webinars in BrightTalk. Okay, the first one was a very high-level one introduction. Maybe even some slides that I have presented here were there. The second one was a hands-on technical webinar. I think it was very interesting and very helpful for people who are interested in knowing technical details of Ubuntu Core. And next week, we are going to compare a little bit Yocto, Buildroot, and Ubuntu Core. Okay. Every platform is great. I think that both Buildroot and Yocto are great. But what we want is to make people understand which are the different niches where they should be used and so on. So yes,
comparing Yocto, Buildroot, and Ubuntu Core. I think the links in the description. I'll go and sign up for that one now. That sounds like fun. All right, I think we'll wrap up properly now. So thank you again, everybody, for coming. Thank you, anyone in the chat, for answering and asking questions. Thank you to our moderators who've been looking at that, and thank you to Amber, who's behind the screen here, dealing with all the presentations and making us look less weird. Yeah, I think if there's, without further ado, I think we'll end it there. Thank you for joining, David. Thank you for speaking, and thank you everyone for watching. Bye-bye.
Bye.